I don't get it. The deadline here says 5th June at midnight. Well, it wasn't midnight. No. Okay. Um, Today is 6th, right? Yes. All right. So those with week 4, kindly try. You have up to 2:30 to upload the document.
Thank
Try
you,
and
sir.
see whether you're able to.
Okay.
Thank
And
you
then
very
I'll.
much.
All right, sure. Has it been successful?
We are trying, sir. Upload the file. Okay.
Week 3, you also have up to 2:30.
Said week 4 is still set at 5th June, 12 a.m.
Yeah, but you try uploading. It should upload.
Okay. Okay.
Sir, please have been successful with week
Okay.
4. Thank you very much.
All right. Okay, so the rest of us, let's try setting up. Week 5 has been live since last week. I don't know whether you guys saw it or not. So let's set up so that we can start. Did anyone see it? See the week 5? Or can you see week 5?
Yes.
Doc, we can see.
Yes, sir.
And is this the first time you saw it?
No,
No.
we've downloaded.
Okay. Okay, so I hope those who are uploading, you finished.
No, yet done. I'm trying to. Yeah.
Yes, sir, I'm true. Mine is done, so.
Okay. All right, so those who saw the week 5, were you able to go through? Anyone, was anyone able to go through? Nope. Silence means no one went through. You saw it. Somebody was last time advocating that I should be sending it earlier. So the last week when we finished the class, I spent the afternoon trying to work on it. And after that, nobody went through. Yeah, Eric.
I went through and then I tried running it. And after I ran each of the code, I think I got some bar charts and some line graphs. And basically, that's what I saw.
Okay. But did you understand what you were doing?
In, for some parts, yes. But honestly speaking, I didn't go through the whole code. I just tried to see the output. And then I saw the graphs. And I just ran through the first code a little, but not for all of them because I was focused on the assignment.
Oh, okay. Sorry. Okay, so I think we can start. Oh, how many do we have? How many people?
Yes, sir, we can start.
Yeah, we have 25 of you here. But some of you are joining with multiple gadgets. All right, so welcome to week 5. And today we'll be looking at visualization and regression. All of these, I don't know whether you guys have been trying to look at the videos that are online. I've been placing online and then also go beyond what I have there. Unfortunately, as I said earlier, or as we started, I don't know whether I said it or not. Not too sure that I said that or not. But because this is more of your first time in Python, we are not able to go into much details, go into deeper issues. Okay. We could have even done a machine learning, which is, if not mistaken, it's part of what AI comes from, artificial intelligence. But we can't go that far. But I just encourage you guys to go through the videos and then do more than we are doing in the class, especially if you want to be a data scientist. Because with this, you're almost there. And now, given AI is able to even do a lot, generate codes and the rest, as we see when we can even ask Gemini to give us describe what we want, and it does that for us. So today we are looking at visualizing and regression, and the amount or the number of visualization we're going to do is just very small, a tiny part of what we can actually do in when it comes to visualization. Now, hopefully you see that when you watch the video I've uploaded in the LMS, and then other videos that you can also watch. Then in terms of even the regression, I don't know how far you went in when you're doing the stata bit. Which course again did you learn the stata? Which course was that? Was it research methods? I've forgotten what you said.
Econometrics.
Econometrics.
Econometric. Oh, okay.
Apply
Econometric.
econometrics.
Oh, okay. Yeah. So I'm sure you did several types of regression. So apart from using a command like reg, which other ones did you use for analysis, for regression? Which other types of regression did you analyze? Apart from OLS, which other ones did you do? Or you didn't do any regression? Evans, did you guys do any regression?
Doc, I think we did ADR.
ADR. Okay, so you even went into time series analysis.
Say, but for us, the January cohort, we haven't done econometrics yet.
Oh, so when are you going to do it?
Maybe the next semester. They haven't given us the details of the next 2 semesters. I'm sure it will be the next semester.
No, okay. The one said ADR, I'm sure you're talking about ARDL.
ARDL, yes, sir.
Yeah. So okay, somebody say ARDL, logit, probit, and okay. Nana Boche, have you been able to upload now? You said you couldn't upload. Are you still here? Boche,
Yes, please. Hello, Doc.
yes,
Yes, please.
you've uploaded.
Yes, please.
Okay. All right. Yeah, so apart from this, logit, probit, ARD, all of these, okay. Okay, let me probably give how do you call it? A disclaimer here. I'm more of a microeconometrician. Okay, microeconometrician. So I deal with micro stuff, household level, individual, but yeah, sometimes go into time series stuff, but I hardly go into time series stuff. So I can't tell. I'm just saying this because I can't tell whether ALDL. I'm sure because these things evolve a lot. So I was going to say whether it can be done in Python, but I'm sure it can. But I'm sure it can. But for logit, probit, and the rest, yes. But what you're going to be doing is just the normal OLS. But I'm saying this just to tell you that what we are going to ask, what we're going to be presented here today is just a continuation of what we've been doing before. But beyond this, you should be given the structure of what you're going to be looking at. You can easily adapt that for when your dependent variable is a binary variable where you can apply the logit and probit. If it is a more than 2 options and it's nominal, then you can do a multinomial logit. If it's a categorical variable but can be ordered, then you can do the ordered logit. You can do truncated uh, models or censored models. You can do what's the name of Poisson, that's count models. All of that can be done in Python. But in terms of what we are doing, we are not, how do we call it, in terms of what I call it, machine learning. Yeah, the machine learning part is not what you're going to be looking at, where the data is split into 2. You train one, so that's where the machine learning comes in. You train one, and out of that, whatever it learns from the data you've trained, the part of the data you've trained, you test it on the other part of the data, but that's not what you're going to be looking at. So we are looking at just the normal OLS. So there's still more that can be done in here, but we are not going that far. Okay, so but I'm encouraging you guys, I'm encouraging those who really want to take this far, don't just end here. Okay, don't end here with where this notebook ends. Okay, so that being said, let's just go into our lesson for today. As I said, we are looking at visualization and regression. And our question is, how can charts and a simple regression help us explain? Okay, so probably let me say, I made some changes again. So what you may have may be different from this. That's in terms of the introduction, but the codes are still the same. We are still going to get the same codes, but the introduction, it's a little bit different. So don't say it's as if it's too different. You still have the same issues that you have there. So where you see the difference, it's not I read that there were a lot of repetitions, so I had to redo it and take out the repetitions. Okay. Okay, so how can charts and a simple regression help us explain Ghana's position relative to regions and lower middle income peers once the data has already been structured and queried? So if you remember from last week we were looking at SQL. Okay, we're looking at SQL. I don't know whether you've been able to practice beyond the assignment that was given. And I don't know, were you able to practice? Did you enjoy the SQL? Something that you'd want to take further? I'm not sure I'll get a response, so let me go ahead.
No, sir, there is the videos. The videos that you uploaded. Watching them also led us to looking at other few material. So yes.
Okay, good to hear. Good to hear. All right, so I said this notebook keeps the core week 5 lesson and then adds an optional extension. So the core part focuses on 3 charts. I said, I'm sure you know when you are talking about charts, there are more than 3 charts. We are going to be looking at bar chart, line chart, and then scatter chart or scatter plot. So there are more charts than we are going to be doing here. So that's what I'm saying, that you want to go beyond what you are going to be doing here. All right. And one simple regression. And the world is not just as simple as this simple regression that you're going to be doing. So again, let's take note of that. So the extension part uses a broader 2024 country level panel, so you can explore more chart types, including a map. So you're going to see that there's going to be a map that we're going to be drawing later on. And then even I think there's going to be, not I think, there is a correlation matrix. Okay, if no correlation, we're going to draw a chart for it. Okay, so same week 5. So week 5 is where we stored and query data. Week 5 is where stored and query data becomes visual evidence. So we are moving beyond where we're cleaning the data to querying the data to get the sub levels and the rest. Now we want to visualize it. We want to see if we can make meaning out of all this data we're doing. Even last week and the weeks before, we were able to get some meanings, do some averages and the rest. But this is the point where if you are doing analysis and to put it into your results section and write on it, this is where you are going to do most of those things. So yeah, so in week 5, you use SQL to build the right tables. In week 5, sorry, that's week 4. In week 5, you would use those tables to create 3 chart types and 1 simple regression. The big goal is not just to make plots. The goal is to choose the right chart. It's just like applying the right tool to the right job. Okay, the right tool to the right job. Label it clearly and explain what the output does and does not mean. So why does this matter for economics? You say economists often need to do 2 things well at the same time. You should be able to summarize a pattern accurately. Okay, it's not only about, yes, I know how to plot, I know how to do this, I know how to do that, but are you able to apply it correctly? So the main thing is being able to summarize a pattern accurately and communicate it clearly. So you're saying charts help the reader see the pattern, and then a simple regression gives one more way to describe how 2 variables move together in the sample. So some of the key terms you're going to be looking at, we have the bar chart. And for bar charts, I say it's useful for comparing categories. So again, this bar chart categories. Sorry. The same bar chart and categories. So it means that you can apply bar chart to a non-categorical data. If you are applying it to a continuous data, you'll be making an error. This is an example of applying the right tool to the right job. So if you have a categorical variable like countries, like regions, then yes, a bar chart is a clear chart you can apply on that. I know you know all of these, but I just want to add more to that. I've been stress on that. Then we have the line chart. The line chart is useful for change over time. If you want to see pattern, and I'm sure when you're doing the time series in Stata, you drew some plots, drew whatever time variable across time. If it was GDP, if it was interest rate, you drew it across time. And the best chart for that is a line chart. Then we have a scatter chart or a scatter plot. This is useful for showing the relationship between two variables. If you want to know how two variables relate, whether they're positively related or negatively related, or there's no relationship or no linear relationship, then if it is even a curvilinear relationship, quadratic relationship, you can see that from a scatter plot. Then we have a fitted line, the line implied by the regression, which in our primary school we're calling this the line of best fit. So if you remember the line of best fit, that is the fitted line. Then we have the predicted value, that the value the model expects for a row, where a row captures each observation. So for ours, each observation are country year level data. Okay, country year level data. So if you want to know, if you are predicting, you run a regression and you want to predict what a particular country gets, then you can look at the predicted value. But you can also get the predicted value of the dependent and as well the dependent variable. We also have the residual. Residual means what is left. What is left. And what is left, also known as the error term. Okay, so the residual is also the error term. So that is the gap between the actual value and the predicted value. So what Ghana reported as if we are predicting, say, GDP, what it reported for GDP, and after the analysis, what did we predict for GDP, given all the other values? So the difference between the actual and the predicted gives us the error or the residual. Then we have the R squared, which shows how much variation in the dependent variable is attributable to the model or is explained by the variables or the independent variables in the model. And it's usually between 0 and 1. That's in decimal terms. But can also, when you multiply by 100, it means it to range between 0 to 100. And the higher the value, the better. It means that your model is explained well by the variables in the model. I'm sure all of these you treated them in the econometrics. Right. So what data visualization is? You're saying data visualization means turning a table into a picture that helps people see a pattern more quickly. Okay. If you have a table and you have a chart would help you to identify the issue quickly. The same information presented in a table form and also in a chart form. You realize that people would appreciate the chart much better, but it doesn't mean that the table is not necessary. The table is still necessary. That's what I tell my students and other people is that if it's the same information, you don't have to present it in a table form, in the chart form, in the same document. One is okay. If the chart will not be too overwhelming, okay, especially when the information is too much, then maybe you can go for the table. But where it's not much and the chart can present it much better, you'd always go for the chart. So don't always try to bring the two together. It's the same information, so you're not adding anything new. So you say here, the chart is not replacing the table, it is helping you interpret the table. Okay, although as I said, you don't need to bring the table and the chart, unless there are some extra information that comes in the table that the chart doesn't bring. Okay, but otherwise, see how you can make it as a note within the chart. Okay, all of these are possible. So why charts helps? I'm sure we already can see that the charts are useful when you want to compare categories quickly. We want to show change over time. We want to see whether two variables move together. You also want to communicate a pattern clearly to another reader. Okay, so if you're losing communication, in fact, if you draw a chart and you have to be there to explain the chart, then you have not done well. The chart must be self-explanatory. So here it says that communicate a pattern clearly to the reader or to a reader. So here the reader could be somewhere. Maybe you've done a publication or you've done your work. Assume you've done your work and then you send it to me, and I have no idea what you have plotted. The X and Y axis is not labeled. There's no title. The grid lines or the axis, in fact, you can't really see what is happening. Then you have not communicated. Okay, so this communication is not about you standing there to explain or you explaining, even in text. Yes, it can be explained in text because you read, but as I said, the chat must be self-explanatory. So we have to keep note of that. So what Python is doing this week? So this week, Python is doing 3 linked jobs. So pandas holds the chat ready or model ready table. Then we have the matplotlib and Sebu. So these are 2 packages that we are going to be used in drawing the charts. But they are not the only packages, but they are one of the popular packages that you would find. Matplotlib and then Sebu. And we have the stats model. So this is where you get almost all the regression that you need. Okay, so if you want to do orbit, logit, and the rest, you have to load this package, the stats model. So that's what we are going to also use to fit the regression model and return the summary values. So you see, our workflow is not random plotting. It is query, store, plot, interpret, and then save. So we'd also learn how to save, or if the command should be able to save it into a folder for us, which you can always go and take and put into your work, or you can also right-click and copy from the notebook and paste into your work. But it's always good to have it also saved in some folders. All right. So why chat types fits which chat type fits which question? I think we even looked at this already, but about chat, we said what categories, and that will help us to compare categories such as region. Line chart, when you want to show change over time or scatter plot, compare 2 numeric variables together, how they change. Okay. All right. So, say a good chart checklist. Does the chart type fit the question? Okay, you want to ask this even before you plot it, before you decide, or even if you don't decide and you plot it. After looking at it, you can decide what I've plotted. Does it really fit the question that I want to answer, the research question I want to answer? Are the axis labels clear? So all of these also adds up to the communication that you are making. Does the title say what the chart shows? Is the year or sample clear? If Ghana is important, is Ghana easy to spot? So here we are. These are questions because of what we are going to be doing. That's why this part also comes in. Okay, because we are going to make in a spotlight on Ghana. So if you want to make a spotlight on Ghana, it means that you want to show it clearly so that anyone who sees it would be able to notice that, yes, this is what we're talking about. Okay, so we look at descriptive statistics before we continue. So why descriptive statistics comes first? In fact, charts like the bar, line chart, and scatter plot, and all most of the charts are more of descriptives. because they help you to describe your data before you do any regression. Okay, so in terms of discrete statistics, it answers questions like what is the average value, what is the typical middle value, how spread out are the observations. Okay, that's if you're talking about standard deviation and variance and interquartile range and so on. Are there unusually high or low cases? Okay, that is issue of outliers. Okay, do we have outliers? Whether it is very low or very high values away from where the majority of the data is. If there are, and you want to take care of that, see what you can do. Either you drop that because it's also going to affect the average or the results that you're going to be coming up with. Okay. So is that this is good. This is why good analysis often moves in this order. So you inspect the data, you summarize it descriptively, you visualize it before you run any model, either OLS or logit or audit probit or whatever analysis you'll be running. Okay. All right, so key discrete statistics in plain language, we have count, we have mean, we have the median, which shows the middle value, the smallest value, and the maximum value or the highest value. You have the range, that's the difference between the minimum and the maximum value. You have the quartiles, where the that's the cut point that divide the data into 4 parts. Okay, so you have the first quarter or first quartile, you have the second quartile, which is the first quartile is 25% when the data is divided into 25%. Second quartile, which is the 50%, which is the same as the median. Then the third quartile, which is the 75th percentile. So the difference between the 75th and the 25th gives us the interquartile range. We also have a standard deviation, a summary of how spread out the values are around the mean. So those who know how to use Excel, if you run the descriptive statistics function, it in fact gives you all of these and even more, depending on what you select. It can give you all of these at once. And we also see that same, I'm sure we've even done that before, but let's see. I'm sure we'll see something like that here also. So these are all discrete tools. They help you understand the sample before making bigger claims. Is that how discrete statistics connect to this week's charts? So we have, sorry, the bar chart which compares group averages. Okay, the line chart shows how one variable changes over time. We have a histogram that shows distribution. Box plot shows median, spread, and unusual values. We have the scatter plot that shows how two numeric variables move together. So descriptive statistics and visualization are not separate topics. Okay, you can use one to replace the other. So these charts often show the same ideas in picture form. Okay, so sometimes not to make your work so boring, if you're doing a research, not to make it so boring, instead of bringing a table of descriptive statistics, you'd use some charts to present your descriptives, and that could also give some life to your results or to your analysis, the analysis that you are running, or the paper that you are running, the project that you are doing. So the last thing before we start, okay, there are a couple of things. Okay, let's go ahead. So what regression means in plain language. So a simple regression is a way to summarize the average relation between two variables in a sample. Okay, so you did that in your econometrics, where you started with simple regression. So you have your y, I, then you have your beta naught, plus beta 1 xi. So we are dealing with just one independent variable. They are looking at simple regression, but where you have more other variables controlling for other variables, then you're looking at the multiple regression. And we know that in this world, there's no single thing that is explained by just one item. Okay, but normally when we talk about demand, we are looking at the relation between like more of quantity demanded and price. And the law of demand, we say holding all other factors constant. But in holding all other factors constant, we are saying that only price, you are controlling for just price, how price affects quantity demanded. But in this world, those other factors you are holding constant, is important. You can't buy any item without income, so you need money. Okay, and all the other factors that also affect even the price of related commodities are also important. If it is a substitute complement, that also affect the quantity that you'd purchase. Okay, anyway, sorry, we're not doing economic. Okay, no, it's still economic, so that's fine. We are still in line. All right, so in the lower middle income sample for 2024, do countries with higher internet use tend to have higher or lower inflation? So we are going to use 2024 data for the lower middle income countries. That do countries with higher internet use. You're going to look at the relationship between internet use and inflation. That's what you're looking at. Generally, all this long sentence is just looking at the relationship between internet use and inflation. How do they relate? So this is a useful. This is that is useful because a chart lets us see the points, while a regression gives us one summary line and a few summary numbers. And I'm sure you remember you saw this when, okay, can I bring it back? Because I can't bring it back, what I wrote earlier. But the intercept was the beta naught. Okay, intercept is the beta naught, which shows that if all x's are equal to 0, what to be the value of y. Then we have the slope. The slope is telling us if there's a change in the independent variable, how does that affect, or how does the dependent variable change? Okay. So how the predicted outcome changes on average when the explanatory variable here also meaning the independent variable, outcome here also implying the dependent variable. So where there's a 1 unit change in the independent variable or the explanatory variable, how does that impact the outcome variable? So that's going to be the slope. That's the beta 1. Then you have the predicted value, which you've seen already, and then residual. So I won't waste too much time on that. We've also seen the R squared, but let's say the R squared tells you how closely the fitted line matches the pattern in this sample. Okay. Although you're not beginners, but we can use this one as a guide. We're saying that the higher the R squared, as I said, it lies between 0 and 1. So anything that is closer to 1 tells you that it's good. So you're able to get the amount of the variation in the dependent variable, you're able to capture more. But if it's low, then it means you are capturing less of that. Maybe let me also say this. We know correlation coefficient. Okay, the correlation coefficient normally represented by R, or either small r or big R. Maybe let me use big R for now. So correlation coefficient, which falls between -1, we'll see that one soon. And +1. Okay. So it is this correlation coefficient. The square of this correlation coefficient is what we know as the R squared. Okay, we know that. So if you look, if you, sorry, nobody's correcting me. This should be positive, not negative. Guys, are you following? I've been talking a lot. Are you following?
Yes,
Yes,
Doc.
Doc.
Doc, we are,
Yes,
we are, we
Doc.
are following.
Yeah.
Okay. So where was I? I was here. Yeah, so I said the correlation coefficient falls between -1 and +1. We'll be looking at that one, a chart like that soon. And so that the squared of R, the correlation coefficient gives us the R squared. So that's the R squared. And any negative number, all the negative numbers here. So if you square -1, it gives you positive. So it means that all of these, anything, all the negative, when you square them, all becomes positive. And then you end up getting, that is 0. So R squared lies between 0 and 1. In fact, I have to make it because they are inclusive. They can be part of it. You can get -1 or +1, exactly. So these are perfect correlation. And also, if you have 0, it means that it doesn't explain it at all. If it's 1, I mean, there's no variation. If it's 1, it means that, in fact, it's a perfect variation. And yeah, people were able to get, I've seen R squareds which are 0.99, like above 9, 0.9 or 90%. That means that the independent variables or the experimental variables you've included in the model are very good. Okay. And yeah, or maybe because correlation also. So normally the perfect one, if you are using GDP, you are correlating GDP against GDP, you are going to get perfect number. So sometimes it's not that it's good. Sometimes if you only added the variable, a closely related variable into the right-hand side. Okay. So yeah, so that is it for the R squared. But again, it says that it does not prove causation. It only gives you an indication. So you then have to go into the model to see, probably talk about causation. But again, causation is quite a big thing because you have to make sure that you'll be able to control for all other factors, all confounding factors, issues of endogeneity. You've been able to solve for all of that before you can actually talk about we can talk about causation. All right, so it's why use a regression after making charts? The charts and regression do different jobs. So the bar charts, okay, all of these we've seen what they do, but the regression line summarizes the average pattern in that cloud. Okay, so the chart, they say the scatter chart shows the cloud of points where how scattered they are and shows you the direction. And then they say the regression line summarizes the average pattern in that cloud. So regression does not replace visualization. It adds another layer of summary. But what can regression do and what can it not do? They say regression helps us describe an average relationship in the sample, estimate a fitted line, and then compare actual values with predicted values. But what it does not do is to actually prove causation, because causation goes beyond just running regression. There are other things that you have to take care of, even whether you are measuring the right variables. The variables that you are including, are they properly measured? Are there issue of omitted variable bias? Have you solved for issue of endogeneity? Reverse causality. Okay, no, I shouldn't say reverse causality because it's one of the sources of endogeneity. So all of that, have you been able to solve all of the issues? Then you can talk about what causation. Okay, but otherwise, regression on its own is not a proof of causation. So it does not tell you that one variable definitely changes the other. Remove the need for economic, that I said by itself remove the need for economic reasoning. Definitely, you have to bring in some economic reasoning behind the analysis that you've done. So a safer beginner phrase is the variables are associated in this sample. Is a common beginner mistakes, plotting the wrong table instead of a chart ready one, forgetting to sort time series by year before plotting. Very important. If it's a cross-sectional data, you don't care about how it is arranged. In fact, observation 1 can go to observation 100 or be at observation 200, wherever you want it. But when it comes to time series, the chronology of the data is very, very important. Okay, how the data is sorted is very important from lower years to higher years. Okay, imagine you mix up the years and you plot, and in the plot, you are having, if I could, you're having, say, 2025 here, then you have 1999, then you have, say, 2007, and so on. And you are plotting a line graph. How would this be able to give you the trend, whether it is trending upwards or is trending downwards? If you should plot something like this, it would definitely make no sense at all. So yes, I know you guys will not do that, so I just have to say it here. So leaving the axis or title unclear, treating a fitted line as proof of causation, and then jumping into regression before understanding the descriptive picture of the data. All right. So what are we going to be looking at today? We look at original summary table and bar chart. We're going to have a Ghana time series table and line chart. We'll have a lower middle income peer table. We'll have some regression summary table and a Ghana fitted value row. We'll have a peer comparison scatter plot with a fitted line and then an optional extension set of extra charts which includes a map. So you're going to see how we can draw some maps when it comes to when you have a data which has, say, if you take like a data on Ghana, you have regions. You can draw the Ghana map, and then instead of, represent instead of a table that will show, say, voter region, this amount, Greater Accra, this amount, you can use the chart or the Ghana map to do the presentation. I'm sure some of you have seen or have heard of heat map before. Yeah, heat map. So that is, you can do that when you have the geographical locations. And luckily, this data, we have the geographical location. Okay. I've talked a lot. I wish I could even go and break before we continue, but let's continue. We can't go and break. I'm just joking. So, as usual, we are going to set up. We are going to load our packages, set up our drive, make sure it is clean and clear, and then do all the setup we need. Okay, so, and Samsung, it's also setting up for the charts and tables and things that you're going to be looking at. It's quite loaded. So all of these are for the charts that you're going to be running. So let's execute this one before and until we can start our analysis. I did it previously, so it's not asking me to mount, but I'm sure when you do it, to tell you to link it to the Google Drive. So I hope you remember how we're opening this. You go to your Google Drive online, go into if you have a the Colab notebook or I had mine in the Colab notebook, so I go into the Colab notebook and open my informatics for economics folder. So let's kindly do that. Are we set up? Is anyone set up?
Yes.
No? Yes.
Yes.
In the process,
In the process. Okay.
I'm done.
Done.
All right. Good to hear. All right. Majority, is anybody still doing it?
yes, sir.
You mean you are done or you are still running?
In the process, almost.
Okay. So whilst we wait, let's look at this. So in stage one, we're going to build a descriptive statistics bridge table or a descriptive statistics table before we move into the same bridge, because we are going to use that one to bridge into the visualization. So before any chart, we're going to start with one broad 2024 country level panel. So this gives you a
I'm
descriptive.
done.
Okay, thank you. So this gives you a descriptive overview of the sample before you move into more focused chart tables. So you said before the descriptive statistics cell, in this first bridge step, you would build one general 2024 panel. We would compute a discrete statistics for the main numeric variables, and then we will do a comparison of few means and medians by region. Okay, so let's take a look at that. So here we are only, again, if you see something like this with an equal to sign, that should tell that it's a placeholder. Okay, I'm sure you know that by now. So we are keeping this, we are saying that let this be equal to that. So build underscore visualization underscore panel underscore 2024 connection, and then link it to the data. Okay, because we need the data. Okay. Hey, please kindly check if you have the data. Did I load any data? Did you have a data? Let me check it from here from my side.
Oh, doctor,
No, sir.
you don't have.
You don't have. Okay,
No,
Yes.
sir.
let me check my folder. So run this. Maybe you get a red, or check if you get an issue when you run this one.
I ran mine, but it's okay. It's run.
It ran.
Yes, mine also run.
Okay. So it should run. Sorry, it should run. Because here is the processed data. So it will go into the processed data. So I think that we are fine. Okay, we don't need any. It's using the data we've been using already. Okay, the data we have been using already, that's what it's using. So we are fine. Okay. So you remember these variables that we're using before: GDP growth, inflation, unemployment, internet users percent, and then internet gap. We're going to draw get a descriptive statistics table, the regional descriptive, and then so let's execute and then see what we get. So for the descriptive, yeah, so for descriptive, and this one is based on only 2024. Okay, so here we are doing everything just on the 2024 data. Okay, no other one. Remember, it's a panel data of several years, but here we are only concentrating on 2024. So it's describing it. Okay, so this command, the describe, is what generates the descriptive statistics, the mean, median, mode, minimum, maximum, standard deviation, and rest. So if you can see from here, generate discrete statistics. Discrete statistics include those that summarize the central tendency, which is the mean, median, mode, the dispersion, the standard deviation, variance, and the shape of a data set distribution. Okay, so that is what it does. Okay. Then it's going to give the values rounded up to 2 decimal places. It will transpose so we can see it clearly. It's a transpose index and columns. Okay. Reset and then rename the variable. So that's what you can see here. So we have GDP. all of also before that, we look at count, which is the number of observations. You can see that all of them are 54. There's no missing observation. We have 54 countries in Africa. And then for that also, we are looking at 2024. So there's no repetition. So 54. So the mean for GDP is 5.4, 8.89 for inflation, and so on. You can see the standard deviation, the minimum value, and then the maximum value. And definitely all these other numbers must lie in between the minimum and the maximum. There's no way the 25th, the 50th, and the 75th percentile can ever be outside of the minimum and the maximum. Okay, so let's take note of that. Okay, so that's what we have. Then we take for the regions. So for Central Africa, the inflation the average inflation rate is 10.38. For East Africa, 7.899, 7.99. Wait, where did I see the 8 from? At least you can see the maximum. Central Africa has the highest inflation rate, and North Africa has the least inflation rate based on this data. Then the median inflation, we just look at the middle value. Again, Central Africa still leads with 10.6, and still followed by North Africa. If you look at inflation, again, we are just considering these two variables because that is what we're going to be using the regression. We're going to apply the regression on. Okay, but you can always go beyond this. There are other variables in the data set that you can always play around with. So we look at internet and we realize that the country that had the highest inflation rate is actually having the lowest internet, the average internet rate here. And then the one which has the least inflation rate has the highest internet penetration rate, or the average internet penetration rate. So this region, the North Africa, countries in the North Africa has the highest internet penetration rate and then the least in inflation rate. So here, if I added this way, at least it can help us with some interpretation. If you are learning on your own, you can always refer back to this just to understand what you have. So the count tells you how many country observations are in the panel. The mean gives the average level of each variable. And I think I will skip this one because I think they are quite basic. I hope I can. So let's go to stage 1. So we're going to query average internet use by region in 2024. In fact, we've seen that here also. Let's do that again. Start from a chart-ready summary rather than a full database table. So this is an important Wk5 idea. So it's a good chart usually starts with the exact table the chart needs, not the whole database. So what's our goal? Our goal is to build a tidy summary table that is ready for a regional comparison chart. So we have the region underscore summary underscore 2020. We're going to run this query, and I'm sure you'd remember this from last week. So you're not going to waste too much time with that. So you're going to give us a table, and that is what we have here. So 87.47 for North Africa. That's 87.47 and so on. Okay, so you can see, say it should order it. Order by average internet users. That is how come we are having the highest before the lowest. And here, I'm sure you remember from this descending order, if I should take this one and then execute it again, it will start from the least value to the highest. I should bring the descending order. Then to start from the highest value to the least value. Okay. All right. So let's, yes.
So for instance,
Thank you.
if you take out the describe, and you
No, this is not described. This is descending, not
descend,
described.
okay, descending, and then you run it. You want to bring it back. What is the command?
How I use the Control Z.
Oh, okay.
Undo.
Okay.
Did they come back?
Yeah.
Yeah. Okay. All right. So let's look at stage 2. Stage 2, you're going to save the original table and create the bar chart. Okay. So save the chart ready table first, then turn it into a bar chart. Yeah, that order matters because it keeps the workflow reproducible. Because you have the table first and then the second. So the spread output here is about the saved table and then the original bar chart. Okay. All right. So before the bar chart, how to read it. So a bar chart is useful when the question is about what comparing categories. Again, this is just a repetition. So the main parts to notice will be the category axis, which would list the regions, the value axis, which would list the average internet use, and then the length of each bar. So normally the category axis will be on the x-axis. Okay, but you can also turn it because you also have the horizontal bar. You also have the horizontal bar. So depending on it, so to be safe, you can say category axis and then the value axis. Then we have the length of each bar that will show the size of the value. So per this, it implies that the longer the bar, the higher the average internet use rate for that region. And per this, we expect that North Africa will have the highest bar, and then Central Africa will have the shortest bar. So let's execute and then see what we get. Has it worked?
Yes, Doc.
Okay. Maybe sorry, 1 second. I may probably update this and send another one, maybe later on. I want to show something. Okay. Okay, so maybe we should have taken our time to go through this one first. And the reason why I want to update this one later is I want the commands that plots the chart to be in the close to where the chart appears. So here, the first thing that we did, the setup that we did also ran all the charts and it has saved it. So if you go into your folder, you realize that all the charts would have been saved. So what we are doing now is just calling them out. But let's look at this one. So this command, for instance, okay, let's start from here. So this one is telling the Python in terms of the size that it should use. So dimension of 10, 6. Then this is the plot, the bar chart that we did using the Seaborn command or the Seaborn package. So with that, okay, so here you have the SNS. So the Seaborn was saved as, it was given an alias of SNS. So SNS.barplot, then data equals data, because the data that we are using has been saved as data somewhere. Would I find that? Where would I find that? I think I would want to break this one down further so that it will be much, it will correspond to each of the cells rather than it being separated, like how I have it now. I'm not sure it is helpful this way. Although this one helps you to set everything fine, but for learning's sake, this shouldn't be the right order. But let's continue. So you have the data, then you have the x-axis. What should go into the x-axis? The x-axis, we are saying it should be the average internet users. Then the y-axis should be the region. So you can see that the y-axis is the category axis and the x-axis is the value axis. Then what should you do? You say you should order the data by region. So you have this, and then you should use this color coding. Okay, you should use this color coding. So when it comes to Python and even R, it uses this kind of numbers as for the coding. Okay, so here, look at this one in terms of the title. So it is setting the title. So set ax.set underscore x label. So the x label is going to be given this label. Okay. So let's see whether that is what we have there. Where's our plot? So average internet users by region 2024. Okay, so that's what we have over there. So you can see that, yes, North Africa has the longest bar and Central Africa has the shortest bar. And the values are all here. Okay. All right. So yeah, so maybe be watching out for, I don't know, maybe I'll save it as a different, I won't replace what you have. I'll just make it as, maybe give it a different name, where inside here you have the actual command that is running the charts inside here. Okay. All right. So did we all have the charts? Is it showing up?
Yes, sir.
All right. So maybe the next one, somebody will do the interpretation, but as you can see, the North Africa has the highest average internet use in 24 at about 87.47%, as you can see from here. So a careful interpretation is that the chart shows clear regional differences in internet use. Okay, if you are writing up, okay, chart shows clear regional difference in internet use. North Africa and South Africa sit above the other regions. So North Africa and South Africa, you can see that all of them are above 80%. Okay. And then West, East, and then Central Africa have the lower averages in comparison. This chart is useful because the question is about comparing groups in 1 year, not about change over time. Okay, again, this is for what? 2024. This is for 2024. Okay, so now let's look at, we're going to zoom into just Ghana. But this time, you're going to look at the data across years. So no more 2024. Okay, so this is a line chart. Again, maybe this will be the last one I'll do to going up. So you can see from Where are we? Yeah, so Ghana, this is the line chart. If yeah, okay, let me just leave it on. So also using the seaborn package. So the seaborn or SNS.line plot, we also need the data. And because you are dealing with two axes, you need a year. So it means the data, there should be a variable called year, and then the internet uses a cent. You should use a marker. So this will, if we plot, you will see some, this kind of symbol in there. Then the line width should be 2.5. Use this color. Okay, give it the Y label. You should title it as internet users into bracket percentage of population. So let's execute that and then see what we get. Where are we? Oh, sorry. This is the first the query to get the table first. So as we can see, as I said earlier, Ghana from 2010 to 2024, we are not more dealing with 2024, which included all countries, but it was grouped by region. But here, we're looking at only Ghana from the least year to the highest year in our data set. So these are our data, and then it has also been ordered. So you can see from the least to the highest. Okay, no, but sorry, not this value. My apologies, not this one. Here, the ordering is on what? Year. So it is on the year. This is a time series data. So it is on the year. That is, if you go and then do it on the internet users, you are going to make an error. It means you don't care about the time dimension. And if you plot anything like that, you can't talk about trend. Okay, so based on that, let's look at our line chart. Okay, let's look at our line chart. So our horizontal axis is time, vertical axis is measuring the value, then the line direction shows whether the series rises or falls. Okay, so because we've ordered it, the line direction becomes intuitive. Tell whether it is rising, falling, or it is just flat, or it is whether it goes up, which is a maximum and falls, or it is a U-shaped graph that we have plotted. So the distance between points helps you see whether growth is gradual or sharp. So let's show it up. So we can see this. At least this one tells us, this is a positively sloped curve that shows us that what internet use has been increasing over the years. Okay, internet usage has been increasing over the years, and you can see that from the data. So even in terms of this, even if you sort it by the percentage, you may get it right, but you can't always assume that there's always going to be increase in a variable. All right, so this is what we have. Did you get the same thing?
Yes, sir.
Any question so far? Or we are fine? Or you ask later? Or I should hurry up and leave your...
No, we are following, sir. We are following. Thank you. So far, so good.
Okay. I thought I should hurry up and leave your afternoon for you to go and enjoy. Okay. So as we can see, Ghana internet use rate rises steadily across what period shown, reaching about 78.7% in 2024. And it's the same as you have here. So what this one can do, at least you looking at the table and looking at this to know that, okay, yes, it is plotting the right thing. But as I said, there's no need, even between these two, which one would you prefer to present in a work?
Graph.
Yes, definitely the graph. The graph. Okay. Let's do another query in stage 5. We're going to query lower middle income peers. So we're going to use one cross-sectional sample for both the scatter plot and the simple regression. So that shared table matters because a chart and a model should be describing the same sample, not two different ones. Okay, so we're going to do some extraction from this table. And I'm not going through this one because that is what we did last week in terms of the SQL. So it is saving this one in LMIC underscore 2024. We have this chart. We have inflation, internet users percent, and then internet gap. So we're going to plot. Okay, so before we do the plot, we're going to run the regression. Again, okay. So we have our model regression data, so that fits this one into that. So this one should go into model and then regression data. The regression summary, so the build the regression underscore summary into bracket model should also go into the regression model. Then what is the path for the data? You have that. And then we run the regression, say send it to CSV. So whatever you get, you should go to CSV. So it means that if you go into our folder, we'll see a new CSV file. So the Ghana fit, we have the regression underscore data dot log. We have regression data taking a country, so specifically Ghana. Specifically Ghana. Then we have country, internet users, inflation, predicted value, and then all of these. Again, let me just take us up there again. Sorry about this. I didn't realize this. I would have corrected it before we met. This is where the actual regression was done. Okay. Up there. This is where the actual regression is being done. We have our X value, we have our Y value, then we are running the regression. So you can see how it is being written. I'm really sorry about how this, but hopefully if I
Sir.
should arrange them. Yeah, Kofi.
Hello, sir. Please, I have a question.
Inusa, yes.
Yes, so I remember from our sessions in econometrics, the data.
Mhm.
Normally, when we have some of these variables, we first find the log form of it in order to reduce like the numbers. Yeah, so that our analysis or our results will be more like accurate. I don't know if with Python, as we are doing, there is somewhere within the code that does the same thing, or because our variables are not that long, that's why we didn't include
They're
something
not
like that.
what? Oh, they're not in log.
Yes.
So yeah, thank you. So normally when you want to log, you first want to look at the range of your your values before you log. Because logging is one way to transform the variable. Yeah, especially if you have outliers, you have large values and low values. When you log them, they all can become much smaller and better. But it doesn't mean that it will solve, sorry, it may even solve the issue of, especially and when it's not normally distributed and you have those ranges. When you log them, bring them together, and those outliers can come closer to the main or the rest of the data. So based on that, if you look at our values, yes, we can log. It doesn't stop us from logging. But if you look at our values, so you take, for instance, the inflation rate, you can see that the highest value here is 10.9, no, 11. So it's 11. Then the least value here is, can anybody see the least value? I can see 5.1. Wait, it's 4.7. Is there anything lower than 4.7? We got 3 point something somewhere. Okay, so highest is 10.6. Lowest is, what is it? 4.7. In fact, let's go back to,
Mine is 10.9.
come again?
The highest is 10.9 or
No, the highest is 11
11.
for Mauritania.
Okay, 11, okay.
Yeah. So let's go
Thank
back
you.
to our descriptive statistics, the one we did earlier. So we come to descriptive statistics. That should even give us an indication. So take the inflation rate, for instance. The minimum value is 4.5. The maximum value is 12. So this is even for the entire data set, not for, okay, no, just for 2024. Okay, there's something we did down there, but usually, let's just use this one for now. 4.5, 12 point. We have a mean of 8.49, a standard deviation of 1.9. So based on this, you realize that the data is not too dispersed. The data is not too dispersed. If you had a standard deviation which was especially equal to the mean or greater than the mean, then you realize that you have some numbers which are further away from the average value here. But here, given this, you realize that it's small, so it's very close to the value of 8.9, 8.49. Now, if we take internet here also, minimum -20, maximum 24.49. Okay, so here, internet it's actually an issue here. 3.49 and then 9.19. So here there is a problem because the minimum value, but we'll probably have to check whether it applies to the one that what we are going to be doing, the data we're going to be using now. But again, when you are transforming also, you have to be careful. If you log negative value, what do you get? What's the log of a negative value? Anyone?
0.
Are you sure? You can search it and see. Kindly search and tell me what log of 0, log of 1 is what? What's log of 1? You can take a calculator and then enter it. Enter log of 1, enter log of 0, enter log of any negative number.
Log of 1 is 0.
Log of 1 is 0. So what will be log of 0?
Log of a negative number does not exist and
Yes,
is undefined.
undefined. What of log of 0? Log of 0? Or the calculator will not allow you?
Log of 0 is undefined.
Yes. So also undefined. So it means that we can't just log internet. Okay, this internet gap. Okay, I think I'm making a mistake. Okay, so if we're doing internet gap, I thought I was using the first one, but this is internet gap. So if we're even using internet gap as our independent variable or one of the variables, there's no way we can log it. We'll have to find a different, okay, maybe let me take that back. We can log it, but we have to do something to it. Okay, we can log it, but we have to do something to it. We can either take the minimum value here, and then add it on to all the values in the data set. Okay, so -20, you add -20 to it. It becomes what? 0. Okay, so you do some other transformation before you find the log. So it's not always as straightforward as that. Okay, so even in theta, sorry, it doesn't cancel. I should put this one into context. It doesn't cancel what you are taught in econometrics. Okay, so please don't go and fight anywhere. Don't go and say that I'm contradicting. At least you are a graduate student, so whatever I'm even saying, you can also go and search on it and make sure that I'm not lying to you. Okay? Whatever correction you have to make, you also make it. In state that there's a command that you also can give. I don't know whether I can divert just just a little bit. Uh, give me a second to divert for just 1 or 2 minutes. Okay, so what do I even want to? Uh, I think what's my command? Let me see. Whether is this one? Oh dear. Let me search for this one. Let me search for it first. My apologies. Okay. Right. Hmm. Ah, you see what I'm doing? There's a spelling mistake. Uh-huh. So it should be E, ladder, not A. It should be E. Please, can you see what I've just done?
Yes, sir.
No. All right. So this command, ladder, and then a variable price. So to even transform a variable, you would always, if you want to run this command, I think there's also its brother or equivalent, which is G ladder. G ladder, there's G ladder. It's running. Let's see what it comes up with. So that's going to come up with a chart. I think. Let me just concentrate on this one. Later you can look at it further. Okay. So the same variable, okay, the same variable. I mean, sorry, the same command is what it has done in a chart form. So what this one is telling us is giving us an idea of what transformation would what we can work. Okay, so for price, so it's not only log. You can see this log here, which is significant. It means that we can log the variable. So in your regression, you can log the variable. These other ones can also be logged. All the ones which are significant. Okay, apart from the last, no, not the last but 3 and 2, inverse and then 1 square, 1 over the square of the variable. All the other ones are significant, which you can apply, which is a form of transformation that you can do on your variable. Okay, so maybe in addition to what you are taught that you logged it, yes, log is fine. but you can also find the square root, you can find the identity, you can find the square of the variable, you can find the cubic. That even tells you that even in terms of this analysis, just putting the square of the variable or the level of the variable that will not be good. You can add the square and the cubic to it. Okay. Anyway, I don't know whether I've confused anybody or you have actually seen something that is useful here. Okay. Did you understand what I was doing here? Sorry. Hello?
Yes. So yes. So the issue of the login, I think from the concept, I think it was thought that if you don't log, sometimes if you find the correlation between two variables and it happens that the one is having like so many numbers, as in
I mean, large
thousands,
numbers, not many.
it's sort of the correlation, getting the correlation, like it's sort of a very, it becomes not so reliable. Yeah, but
Okay.
we get the concept from what you are showing us.
Okay. So yes, so whatever be the case, just go and then read on this one also and see how useful it could be when also you want to do some transformation. I just wanted to point out that it's not only log that can be used, because if I find the square root of a variable, I'm also reducing the size of all the variables. And sometimes too, you don't need it's not even the log that you need the square of it or whatever it is. Okay, so let me just take to the internet use. I think that was the variable that we are going to be using. So the minimum value here is 48, the maximum is 95. The mean is 68.41, the standard deviation is 12.90. That is not too bad. I mean, it's not bad. Okay, so when it comes to this one, I don't really need to find the log of these variables. So I'm just saying that you can use the standard deviation as a check on whether you should log a variable or not. Okay. When the other bit is when it comes to data science, for them, even the advice is to standardize all the variables so they are almost all of them are in the same sort of range. So in terms of this, we'll have to standardize GDP or I mean, all the variables that you're going to be using. You have to standardize them so that they are all when you are doing analysis, one measured in a different metric and another measured in a different metric, and then you are running the same running analysis on them. It would not be helpful. Okay, so that is an advice. At least add it on to whatever you've learned from econometrics. But again, you don't always have to take our words for it, given the amount of information that is available for you to search. So please don't take my word for it. You can go and then search. Okay. All right. So what were we? Somebody's playing music at the background. So if you know music at your background, kindly mute so that after that we can all join you for the party. Okay.
Majid.
All right. So let's go ahead. So as we've seen for this, we saw for, or we are now come to see, okay, we saw for internet that the highest is 11, the lowest is 4.7. So this is the range is not too bad. Okay, so when you have these kind of low values, which are quite close together, for me, for my side, there's no need to log. Okay, then when I take the internet users percent, as we saw earlier, let's look for the highest value and the lowest. I can see 53.4 here. Can anybody see anything lower than 53.4? It looks like, was it arranged by internet? Okay, it was arranged. So you can see from here, it was ordered by internet users. So this is the highest is 94.9 The lowest is 53.4. Again, if you run discrete statistics on this standard deviation, we are not going to get anything huge. But again, Inusa, you asked the question. You can always also find the log of the variable in here before you continue. So it's also possible. Maybe I should have just answered it that way. All right. So,
Okay, sir.
so let's execute. Let's go to stage 6. After seeing this, we now want to get our regression table and see how we can do the interpretation. So let's execute stage what? Stage 6, which gives us a table and then our output. So you have the intercept and then the slope here, because you're also dealing with just two variables. Or we could check on that. So let me just get it from there rather than going up. Okay. So is that here the fitted slope is about negative 0.067. That means that in this sample, countries with higher internet use tend to have slightly lower inflation on average. So here our analysis is on internet use and inflation. Okay, so the effect of internet use on inflation. So if you take here, for instance, this is the intercept. So if internet is equal to 0, the inflation rate is going to be 12.3979. So that is it for this. Then for the slope, we're saying that again, so the way we would have seen it in Stata is not the same way as we are seeing it here. Okay, how Stata presents its regression table. That is not how Python or R presents this. Okay, so that's how come we are seeing it this way. Okay, and this even is all this because we have arranged it. That's why it's coming this way. So it doesn't come again. Just to let you know, it doesn't come the way you see the F statistics, the R squared, and all these other things. The sum of squared error before the actual table that shows you the results, gives you the confidence interval, and so on. That is not how it shows up for R. I mean for Python. Okay, so here, this is the slope coefficient, which is if internet increases by 1 unit, by how much does inflation change? And this is negative. So you can see that there's a negative relationship between internet use and inflation. And per this, a unit increase or a percentage increase in internet use. Internet is measured in percentage. So a percentage increase in internet use reduces inflation by 0.0654. Yeah, that's what we have here. So a careful interpretation here again is that a negative slope suggests what? A downward association in the sample. Okay, showing that negative association between the two variables. Then the intercept is part of the line formula, but it is usually less substantively interesting here. Okay, because normally, especially, okay, maybe for this, let's think about it. It may make sense. Let's all think about it. We are looking at the relation between internet use and then inflation. This one is telling us that if internet is equal to 0, inflation would be this amount. Okay. The question is that can that be true? Or the issue is that this is also capturing other things that other variables that we've not included in the model. So it has increased the value of the intercept. Increase the weight of the intercept. So maybe we will not want to add it. Sometimes even it doesn't even make sense to say when the independent variable is equal to 0. Okay, let's take for instance, you have let's say the price of a house. Okay, the price of a house. And that one we have beta naught, okay, plus beta 1, and then the size of the house. Okay, in analyzing, let's say after doing the regression, we had beta naught to be, let's say, 24. Okay, just for example, beta naught is 24. So you are saying that if the size of the house is equal to 0, then the price of the house will be equal to 24. Does it make sense? Somebody tell me something. Does it make sense to say that when the size of the house is equal to 0, the price of the house is $24, 24 cedis, whatever? Don't forget about the, just forget about the, forget about the money. Or let me make it let me say $2,400. So let me make it this way. So talk to me. Let me know if you understand what I'm saying. Do you understand my question?
Yes, sir.
Okay. So does it make sense?
No. If
Why
if
not?
the, if the size of the house is 0, meaning you are looking at no house at all. But then
Excellent.
because there's a factor that is considered in the equation, you still have value for something that is non-existent.
Yeah. The house doesn't exist. If it's equal to 0, it means it doesn't exist. So there can't be a price for a house that doesn't exist. So in terms of this, like something like this, that is why when it comes to the interpretation, you have to be very intuitive in it. Look at what you are analyzing and see whether, if you say something is equal to 0, does it make sense to interpret the intercept as it is? Okay, so hopefully you get what we are saying. All right. So, okay, let me, yeah. So we go to the R squared is about 0.1358, whereas to the R squared is 0.1358. And then the adjusted R squared is 0.0903. And I'm sure you were taught what adjusted R squared is. And the only downside when it comes to the Python and rest is that it doesn't give you all the other information that I'm sure you can bring them out, but you see how when you run regressionist data, how it just comes out. That's not how it comes out here. So we don't see all the other information. The RMSE, what's that? Even in terms of, okay, this one, the adjusted R squared is here. Okay, but here it's fairly low. Okay, it's between 0 and 1. And this number here is closer to 0 than to 1. So you can just see that it means that the fitted line explains only a modest share of the variation in the dependent variable. Okay, so it doesn't really explain it much. So something like this, it should tell you that, oh, okay, maybe, there are some important variables that has not been included in the model, which has to be included. Then Ghana's predicted inflation is close to its actual inflation. So let's look at that here. So this is inflation rate, which is 7.8, and then the predicted inflation rate is 7.6368, which is quite close. Okay, although it has been able to predict close to it, but again, we are saying that based on our R squared here, the variation in the model has been poorly or lowly explained. Then the residual. So, but let me probably make this point that all the interpretation that you learned in econometrics applies here. Okay, it also applies here. So let's take note of that. Then our residual of inflation is just the difference between this inflation rate and the predicted inflation rate. Maybe somebody can check and see whether it is right, getting 0.1632. Okay, the only problem is that this one does not give all the other it is only up to 1.1 one decimal place. So you won't get this whole thing. Okay. Any question? All right, so we want to create a scatter chart with a fitted line. So the scatter chart lets you see individual countries, while the fitted line summarizes the average pattern across them. So that means the chart and the regression are working together. One shows the point, the other summarizes the trend. So for this, I should ask you questions. So what each point represents, what fitted line represents, what Ghana sits relative to the line. So let's plot and then we can probably look at that. So let's execute this and get our chart. Okay. So you can take a look at yours. My page looks quite, let me see if I can reduce this to get it to fit in. So we have this chart. Did yours come up?
Yes, sir.
Okay.
Yes, Doc.
All right. So only 2 people had theirs coming up. The rest of you, I hope you are
Yes, sir.
following.
Mine is up.
Oh, okay. All right. So we have our inflation rate against our internet users. So we have the actual point, and then we have the fitted line. That's the line of best fit. And based on that, we realize that what we have, is it upward or downward sloping curve? No answer. Okay. So we have what a downward sloping curve showing what a negative relationship between inflation rate and then internet users per percentage. Sorry, per percentage of population. Sorry. Okay, so as we can see, and this point gives us these. So we have the green for, is it? No, deep, these greens here for North Africa. And let me just go up so we can understand why. So per this, you can see we had these number of North African countries. We have this, we have that, we have this. Which other one do we have in our data? So there are 3 of them. So 1, 2, 3. So you can see how can we have this 1 and the 2 and then a 3. For these other ones, South Africa, Southern Africa, which color is that? An orange. So orange. So this orange, you have 1, 2, 3, 4, 5. So it means that if I come to the table, I should be counting about 5 Southern Africa. So I have 1 here, 2, 3, 4, 5. Is there any other one? No other Southern. So there are 5. So that's how come. So that's what is being plotted here. So it is plotting the inflation rate against the internet users rate. Okay, so North Africa 8.2 against 94.4. So 94, so around here 94 against 8.2. So this one is Morocco. Okay, this green here is Morocco. Okay, so because we are also looking at Ghana specifically, okay, because we are looking at Ghana against the other regions, we are also including the data on Ghana. You should plot that also. And we look at this, we have Ghana is here, which has the inflation rate just lower than 8. It's just below 8. And then internet users rate closer to 80%, but just lower than 80. So you can just confirm in the table. Somebody seeing Ghana, yeah, so Ghana 7.8 against 78.7. So you can see that that is what has been included in here. Okay. Again, this is not showing everything. If you want to see the entire command, I would have to currently we'll have to go up there to see it. Okay. Any question on this? All right. So what you're doing is this the okay? I think we've seen that it's downward sloping. Okay, we've fitted in the line of best fit. If you look at Ghana, is just above the line of best fit. It's close to it. Okay, these ones are some sort of outliers. They are further away from the line of best fit. And one thing that you can notice with this is that the further away the points are from the line of best fit, it means the lower the R squared. Okay, the lower the R squared. The closer the points are to the line, it means that it's been able to fit it. I mean, it's a best fit for it. R squared is also it's used to check for the fit of the model. Okay, so that's why the goodness of fit. So here, as I said again, where the points, the points here are further away from the line of best fit. Can we say, probably let me get your view. Can we say that these points are not close to the line? Are they are further away from the line of best fit?
Yes, Doc.
Okay. So
Yes, yes.
if they are, as I said, if they are close to it, then you should know that the R squared you get a bigger R squared. If they are further away from it, like we have now, that's when you'll be getting the smaller R squared that we saw earlier, 0.1 something. Okay. So here it is just picking up the values to report. The top region, North Africa, it is 7.47. Ghana internet is 78.7. Then the rank is the 7th. Regression slope was this, and then the regression R squared was 0.1358. So that is what we've done. Has somebody checked if the charts have been saved in their, so here, this part created new folders. So if you check, you realize that a folder called outputs has been created. And that output, you have tables and then figures. Can you confirm if you can see that? Let me give you some few
Yes,
seconds
Doc.
to check that.
Yes, Doc, is there, yes.
Yes. Okay. And can you see the figures in there and some figures in the figure folder?
Yes, Doc.
Charts. Okay. All right. So we'll be doing some extensions soon, looking at some other types of charts, which I thought was quite important. So in our main chart, we looked at only 3 charts. That was the bar chart, the line chart or line graph, and then we've just seen the scatter plot or the scatter chart. Okay. And for me, normally also you can draw the chart first. That's where the scatter between the two main variables of interest, just to get an idea of the kind of relationship that there exists between the two variables before you even do the regression. And usually also that can also give you an idea whether you should be expecting, whether you should square the independent variable or add the square of the independent variable to the regression. But sometimes when you plot it, you realize that you are getting a U-shaped curve. So you're getting a U-shaped curve, then you should be adding the square of the independent variable into the model. The relation between the dependent variable and the independent variable is not linear. Okay, so we take a look at this is putting the core outputs together. The original chart shows, okay, so it's just explaining this. So let me just skip that one. So later you guys can look at it further. So let's look at the extension. So the next stage are optional, but we are doing it anyway. So they keep the week 5 economic story, but widen the chart menu. So let's look at it. So stage 9, build the general visualization panel. So we're using the data we used earlier So up to this point, each chart has used a table built for one specific question. So the general panel is different. So each row is one country in 2024. Several variables are stored in the same table. That lets us ask broader visual questions such as distribution. So here is in terms of the table that you are going to be using. So the visualization panel, again, it was done earlier. So again, I'll try to bring them together. Okay. So this is a table that you are going to be looking at. Just bought 12 rows, as you can see from here. So with 10, we're going to create a histogram of internet use. This will tell us the distribution of internet. Again, this is even still useful to even do before you run any analysis on the variable. Okay, especially if this variable is the dependent variable, you want to run the histogram of the variable or box plot of it, or look at the distribution of this variable to make sure that it is not very skewed before you use it for running any analysis. So what is a histogram? So a histogram groups values into bins. So the main part to notice is that each bin covers a range of values. The height of the bar shows how many observations fall in that range, and then the overall shape helps you see the clustering spread or the skewness. Okay, especially what is skewness. So a histogram answers a different question from a bar chart. We realized that the bar chart was used to compare categories. Okay, compare between categories, but the histogram is used to show the distribution or to identify the distribution of a variable. So let's execute this. Again, the command for this to run the histogram is already there. This one is just calling it out. So we look at this. What do you say concerning it? Is it normally distributed or it is skewed? If it's skewed, is it to the left or to the right? Is it right skewed or left skewed? Any contributions?
So it's not normally distributed. Depending on how we are facing, I think if I'm looking, it's left skewed. So it's more steeper towards the left compared to coming to the right.
So it's steeper
at the left side. Looking from how I view it. I mean, holding or looking onto my screen.
we should all be seeing the same thing. It shouldn't be
Yes,
different.
yes, sure. So it's left skewed. It's more abrupt or more elevated at the left end, and then it sloped steadily towards the right side.
Okay. Do you all agree with him? Or who else agrees with him? If I say all of you, not all of you mind me, so let me just reduce my expectation. So who agrees with him?
Yeah,
That
I
is
agree.
that is what left skewed.
Yes, because with the left side, that is where more of the percentage of internet users are. But when it comes to the right side, the percentage kind of drop as it's going down.
Okay. All right. Is that we all agree? Is there a third person to agree on this?
Doc, please, if you can come with the explanation again, the interpretation.
Me? No, I'm not the one interpreting. No,
Oh,
it's your
okay.
kids who are interpreting. So I'm listening to you. What do you think? Priscilla, it looks like you have another machine by your side. Okay.
Yes, please.
Yeah. So are you agreeing or you are disagreeing with them?
Sorry. Please, I disagree.
Okay. So the other machine, you probably have to reduce the sound to the barest minimum before you can talk. As we
Hello,
are,
Doc.
yes, Jennifer.
Okay, so I would say I disagree because I see it to be more steeper at the right side than the left side.
Okay.
Yes.
So you are saying it is right skewed and not left skewed.
Yes.
Okay. Priscilla, is that what you're going to say?
Yes, please. That's exactly what I was also going to say. That it's right skewed and
Okay.
not left. The fact that the left side looks like there are a lot more higher values, it doesn't mean that it is left skewed. It's right skewed because when you look at the tail, realize that it's dragging. It has a longer tail moving to the right side. So it's more of right skewed than left.
All right. So that is it. So Priscilla has just nailed it. So yeah, Priscilla and Jennifer, yeah, Jennifer got it. So you normally look at the tail, the part that has the longer tail. Okay, the steeper side or the longer tail tells what sort of skewness. I know it's kind of confusing because you say that majority of the information is on the right, but why are we saying, on the left? So why are we saying that it is right skewed? Yeah, Anthony, you disagree, eh?
Doc, I want to agree with the
First person.
current, yes, the Priceless point of view. I mean, looking at the axis, the number of internet users as a percentage of the population, you are going into the hundreds to your right, where it is sloping and has a long tail. So definitely, if we want to consider the left side, we have just a few number of internet users from 50, 60 up to somewhere around 65, 68. And then from the 70 to the 90s to the hundreds, you see that a lot more people have access to internet than the left side. So I would agree with the second point of view from Prince Lanko.
Okay. Yeah. So always, who is calling? iPhone, you are calling.
Yeah, Joseph Ken.
Okay.
Please, can you also say that it has a concave shape and then it's skewed to the right and therefore it's normally distributed.
In terms of normal distribution, wouldn't say it may be close, but it's not normally distributed. Okay. Yes, it looks like concave, but it's still not normal because we have one tail longer than the other tail. Normally, it is, I'm using normally again. If it should be normally distributed, then we should be seeing something like this. Okay. Maybe something close to this, not like I've drawn it, but something close to this. Okay, then you can say that is what's normally distributed. Now, where you have the situation where one side is longer than the other, then it is not normally distributed. So where the tail, the part which has the longer tail takes the name. Okay, don't worry, me too, when I was learning for the first time, I was confused in terms of why the tail should be taking the name, but whoever designed it gave it that way. So this one, the tail is on the right, the longer tail is on the right. So we have what the right skewed or positively skewed, and the tail is on the left, so it is what left skewed or negatively skewed. So that is it for this. So as you can see from here, the tail, the longer tail is on the right. Okay, and again, if we're looking at ketosis, okay, ketosis tells us how how do I say it, how peak the the distribution is, because that also gives an indication of normality. Okay, the data is normally distributed. So this one actually looks like plateauketic. Okay, so plateauketic more or less has something like a more of a flatter top. Okay, like a flatter top. And then we also have the platyketic, which has a longer, so something like this is yeah, I think platyketic. And this is plateauketic. Hey, am I missing? I hope I'm getting the name right. Then we have the mesoketic. The mesoketic is that one is the normally shaped one. So also, we can also use that, how peak it is. And because this one more or less like is looking like a flat top, it also doesn't depict normality. Okay, it doesn't show that it's normally distributed. So let's go and look for the names of I know it's mesoketic is the normal distribution. Plateauketic or the platyketic is the one that has more of a flat top. Then we have the lepso. I think it's lepsoketic. Okay, but again, don't take my word for it. Let's check with just searching. Now AI will give you everything, including things that you don't need. It will give it to you. All right. So let's look at the box plot. So the box plot of inflation. And in terms of this, what you're going to do is also plot it by region. So you can plot it individually. Not individually. You can plot everything together. But here we're plotting it by region. So we execute, and then we have our box plot. So box plot also allows us to see the distribution of a variable. Okay, the distribution for variable. And we can see for inflation, based on this, we can quickly see which region has the highest inflation and which region has the least inflation and where they are mostly concentrated. Okay, so as you can see, the Central Africa has most of its inflation concentrated between just a little below 10% and a little below 11%. Whilst West Africa has more of a wider spread. Sorry, let me take that back. Let me take that back. But it's still not wrong though, because the concentration is still between that. But the minimum value is this tail here, the short tail here. So this line is the minimum value, and the maximum value is this whisker here. Okay, this line that we have here. So there's the minimum and there's the maximum. But that's telling us that what 50% of the data is concentrated here. Because this box, this part here, this part here, okay, this line here, sorry. This line here is the 25th, okay, is the 25th quantile. Okay, 25th, what am I find difficult to write? Then this line, this part here is the 75th. And then this line in the middle in the box, the line in the box is the median, the 50th percentile. Okay, so you can see that 50% of the people are concentrated in the same way. That's also said that it's concentrated there. But otherwise, the minimum is, oh, what's happened to my mouse? The minimum, sorry, my mouse is not moving. 1 second. Yeah, so the minimum is the lower, this lower whisker, and the maximum is the upper whisker. Okay. So West Africa, we can see where the 50% of the data, the middle 50% where they lie. Okay, ranging between just a little above 8 to just below 11. Okay, but if you take, for instance, although Southern Africa has one of the lowest inflation rate, but I can see that it is quite highly spread. So North Africa will say is much better because although, as I said, South Africa has the lowest, North Africa has most of its people in the lower bound or the lower range as compared to the Southern Africa. Are we good? Did you get what I've been trying to say? Any question?
No, Doc, kindly take what you explained again for me, please.
Well, I should start from where? The top.
Yes, please.
Okay. Who understood what I was saying? Who understood anything I said? Anybody? Help us with explaining. Or I should do my own thing. I guess the answer is I should do my own thing. Or iPhone, you do it. Or help me. Let's go. Sorry, when you always mention your name, I don't get it. If you change your name, I always remember who is talking. Go ahead, please.
Joseph Kenanti.
Okay, Joseph. I hope I remember next time. Kindly go ahead.
Uh,
Are you talking? I can't hear you.
no, sir, I'm not talking.
Oh, I thought you were going to help us explain. Okay, let me just do that quickly. So I'm saying that just like the histogram, which allows us to see the distribution of a variable, another chart that helps us to do the same thing is the box plot. Okay, so with the box plot, you can see we have the minimum, which is the lower part of the whisker, and then the maximum, which is the upper part of the whisker. Okay, this is called a box and whisker plot. So this is the box and then a whisker. So we have this bars. So for all of them. So whichever one I'm explaining, it applies to all of them. And this, the beginning of the box. So the beginning of the box gives us the 25th quartile. And then the end of the box gives us the 75th quartile. Then the line that in the line in the middle of the box, dividing the box into two, is the median. Okay, is the median. So probably let's link this. I know we plotted that, we saw that. So we're going to look at Central Africa. So I'm going up and then let's take note of the values for Central Africa. Where did we get that? So Central Africa, we are plotting, I believe, inflation. Okay, we didn't do, okay, we can't get that one here. Oh, we can't get that one, so go back. Okay, so with that, yes, so look at, sorry, so who was it? Jennifer? Jennifer, do you understand this, what I've just said?
Yes, Doc.
Yeah. So the same for West Africa and the same for all the other regions. So if you're looking at normal distribution, Then you should be thinking about a box plot of like, which is something like what I am going to try to plot. Okay, so something like this. Okay, maybe so something like this. So based on this, it's more or less like the length, this length is the same as this side. And the box is also divided in two equal halves. So when you have something like this, a box plot of this nature or anything close to this, then you can see that what your variable is normally distributed. Okay. But where you have this, can you say any of these are normally distributed?
No.
No. Here has a shorter tail and longer tail. And also an indication, the one which has, the longer whisker, the part which has the longer whisker shows the distribution, whether it is positively skewed or negatively skewed. So something like this, you realize that the whisker is on the right, the longer whisker is on the right. So this one is positively skewed. West Africa will be what? Positive or negative?
Negatively skewed.
Skewed. Okay. This is quite going to East Africa will be a trick, a tricky one, as you say. Or has somebody found it?
It will
It
be
is
it will be sort of
positively
positive.
skewed.
Yes, positively skewed.
Why positive? Why negative? I had two answers.
So it's positive because when you look at the two ends, which is the 0 to 25, and then from the 75 to the 100, the middle one, when you look at the middle, which is
Yeah,
between
this
25
one.
to it's more to the right than to the left.
Okay, good. Yes, so that also gives you an indication. Okay, so that also gives you an indication. So yes, so this will be what positive. Okay, all right. I hope you all got it. Did you all follow?
Yes, Doc.
Yes,
Thank you.
Doc.
Okay, good. Today I'm missing somebody's voice. Let me see who that is. I've forgotten the name. Is it Abraham? Abraham, are you here? Is there one called Abraham in this class? I'm sure there
Yes,
is.
there is.
Yeah, today he's very quiet. Or he's getting it. You are getting it, so you are quiet today. Hope you are okay. Abraham.
Thank you, Majid.
Ab-
Sir, I'm here.
Yes, this voice. Why are you quiet today? No answer. Okay, no
Oh,
worry.
it has been raining since morning. I don't know, but I'm still around inside the room, enjoying you.
I hear you, boss. Okay, now let's look at correlation table and a heat map. Okay, correlation table and a heat map. So a heat map is a compact way to compare several pairwise relationships at once. Saving the correlation table alongside the figure keeps the numbers behind the colors visible. So I mentioned earlier, for correlation, it ranges between -1 and +1, where +1 means strong positive relationship. In fact, it should be perfect positive relationship. Okay, no, sorry. It said values close, so I take it back. So values close to 1 is strong positive relationship. Then value close to -1 is strong negative relationship. Then values close to 0 means what? There's little linear relationship between the two variables. So if you're going to use a heat map to represent that, so each cell is one pairwise correlation. Okay, one it shows the correlation. If it's a pairwise, it means it's taking the variables two at a time. So that's the pairwise is looking at here, or it's mentioning here. Then the diagonal is always one. So the diagonal is more or less a relationship between the variable and itself. Okay, so that's what the diagonal will show. So that one will be perfect throughout. Then the correlation scale helps you spot stronger positive or negative values quickly. The correlation is descriptive, it does not prove causation. So let's plot our correlation matrix. So we have this, and sometimes you can do it without the figures. Okay, you can plot without the figures. And as I said, the diagonal, you look at the principal diagonal, it is GDP growth against GDP growth. This one, inflation rate against itself. So very perfect. Okay. But beyond that, if there were no colors, if there were no numbers, we use this scale to at least determine which one has strong relationship and which one has weak relationship. So you can see the 0 is kind of close to, or as it's getting closer to 0, it is fading. The color is fading. This one was a deep blue, and as it got to negative 0.5, it is kind of lighter. And as it's getting to 0, it is kind of fading. And the 0 part, you can see that it's kind of white. Okay. Same from the top. So based on that, we can see. And again, you can determine that all the this color brown light colors are the positive relationship, and all the colors that are blue are the negative relationship. Okay, that's per this scale. So you can see that there are a number of blue colors, and the blue colors are also shaded. They are different shades. The deeper the blue, the more negative it is. When it comes to the brown also, the deeper the brown, the more positive there is. So you can see here. Okay, so again, whatever is down here is the same thing up here. It's just a mirror reflection of it. So here, for instance, is the relation between GDP growth and inflation rate. And that's the same thing here, inflation rate and GDP growth. So you can just concentrate on one side rather than concentrate on both sides. So let's just concentrate on this, the downside. You can see this is very deep brown, 0.93, very high. And that is a relationship between inflation gap and inflation rate. So this one should tell us that what inflation gap and inflation rate are highly correlated or highly associated with each other. But we're not saying causation. We're not saying that one causes the other. We're only saying that it is highly correlated. And another kind of deep brown is this 0.67, which is a relationship between internet gap and then internet users percent. And at least I think it should be expected. Okay, it should be expected because in calculating internet gap, it was the internet users percentage, and we subtracted the threshold, which I think was 70. So in calculating internet gap, we use the internet users percent. So this variable, this number should not be too surprising. Then we come to 0.51 here, which is almost in the middle. In the middle of the range, which is internet users percent against unemployment rate. Okay, so it's positive, which shows that higher internet users percent is correlated with a higher unemployment rate. So you can say same for the negative values also. You can see that it's also ranging from negative values, different shades of the blue. We have this 0.005. You can see that this is almost closer to white, which means almost closer towards 0. That tells us that what? There's kind of in fact, close to no linear relationship between inflation gap and GDP growth. But when we come here, we have kind of weak negative relationship. Okay, this is positive. So yeah, so it is coming from okay, so you can see it's positive brown. Okay, but here negative 0.21, which shows a weak negative relationship between internet gap and GDP growth. The highest negative you can see here is 0.44. Can somebody see anything beyond that? So I think that is it's negative 0.44. Then that is between internet users percent and then inflation rate. So I mean, not both, they have a negative relationship or association between internet users and inflation rate. So this is a moderate relationship, okay, moderate negative relationship between internet users and inflation rate. All right, so this is the heat map, the correlation heat map. Are we good with the explanation I've given?
Yes.
Okay. Then we're going to plot a bubble chart. So say a bubble chart lets you compare two variables and then use bubble size for a third one. So here, internet use and inflation stay on the axis while unemployment changes bubble size. So you'll see that it's going to be more or less like a scatter plot, but the bigger the bubble, the bigger the unemployment rate for that particular country or relationship. So the x-axis is going to show one variable, the second variable will show the other for the y-axis. Then the bubble size adds a third variable, and the color can add a fourth cue, such as region. Okay. Then, so this makes the chart rich, but it also means you should read it slowly, not try to interpret everything at once. So let's look at our bubble chart again. When you go up there, you'll be able to see the command that did this. This is just calling it back. If not, we are just plotting it, but if you go to the chart, you realize that it's already there. Okay. So here we can see two scales, or yeah, two legends. One for the region, and then another for the size of the bubbles. So telling us that is as big as this, then you are getting 12. The inflation, so the unemployment rate is about 12%, followed by 10% up to 4%. You can see Ghana. Ghana, where are we? 10 or 5%? 10 or 12? Who can see anything? But can we see the size of Ghana, which has been shown clearly here? Okay, well, you can see this.
Yes.
Okay, thank you. We can see these smaller ones also showing the relationship. So all of these, if you want to draw a line of best fit, is it going to be positive or negative line you're going to draw? I mean, downward sloping or upward sloping curve?
Downward slope.
Yeah, so a downward sloping curve, like a demand curve. Okay, showing the relationship between inflation rate and internet users. And we can see it for each of the region. And at least, even if you look at the green, some countries have higher unemployment rate. Their internet use is higher and inflation rate is also high. But this one is small, which I think about 6%. Okay, it's small, has a lower penetration rate for internet use, but their inflation rate very high. Okay, which one can we take? This is another very small one, which I think is even lesser than 4. Okay, this may be lesser than 4, maybe about 2. And this has just above 70, has a very small, lower unemployment rate and a low inflation rate. Okay, low inflation rate, kind of high internet users rate, and it's even above the threshold of 70. and it also has a low inflation rate. Yes, Isaac.
So, Doc, in effect, this chart shows, I mean, it gives the relationship between three variables at the same time, right?
Yes.
So
And also,
basically, that's what it does.
yeah, and even breaks
Okay.
it into the regions also. So there's even a fourth one, which is the region. So the regions are the colors, the
Yes,
different
yes,
colors.
yes.
Mm. Okay. All right. So any question on this one before we move on? I think to the very last chat. Okay. So if there are no questions, we'll move to the spatial chart. The spatial chart, which is called the chloropleth map. So this is a chloropleth map which colors areas according to a value. Okay, the main parts to notice is each country is identified by its ISO 3 code. The color scale shows whether the value is lower or higher. Okay, so I would see that one also in terms of the scale. And over information lets you inspect the exact country values. So the spatial charts are useful when location itself may matter for interpretation, or when you want to spot a regional clustering visualization. So this regional clustering visualization, it's problem explained further. If you take, for instance, let's take a map of maybe districts in Ghana on, say, food security, and then you plot and realize that there's a similar color, or very the range of that color is around a certain location. Districts around each other have quite similar color. That tells you that what those regions are more of clustered. They are more of having similar characteristics. Okay, so let's see what we get for our African map. So for our African map, this is what we have. And this is the internet gap. The internet gap. The is it a would I say blue violet? The which color is it, blue or violet? I think it's violet, right? Or deep blue. No, it can't be deep blue. But this colors here shows what positive, and this color here shows negative in terms of the gap. So the red shows an issue. And here you can, from this one, you can quickly see which country has a red, has a negative, what's the name? Or very negative, because it's not only that. Okay, very negative gap, very far away from reaching the target of internet penetration in the country. Like, who knows? Okay, so you put on it, you have what? Can you see the country? When you hover it, can you see the country? Which country did you get?
Cameroon.
Cameroon. Yes, and there's also just below it. Okay, just below it also you have Equatorial Guinea. I didn't know Equatorial Guinea was this small. Can you see what I'm saying? You
Yes,
see
Doc.
just below
Yes.
Cameroon, you can see a very tiny country there. I think it's as close as Lesotho. Let me see. This Lesotho, also very small. Okay, so Lesotho and Guinea are fighting for Equatorial Guinea are fighting for the smallest country. Hey, we also have Gambia. Is it Gambia? Gambia. Anyway, but at least we can see what's
No.
happening. Look at all the countries, the North African countries. Okay, the North African countries, you realize that all of them surpass the internet internet threshold, internet penetration threshold, because they are all in the blue. So it means that the deeper the blue, the more penetrated, the more closer to 100 there is, or the further away from 70 it is. So you can see this one is Morocco is 24.9 away from the 70. So it means that the penetration there is 94.9%. As you can see up there, internet users 94.9%. Okay, so for all the countries, you can see that. Yeah. Then you come into West Africa, and you can see that it ranges. We have others who are still further away from the threshold. A country like Mauritania is 5.5 below the threshold of 70. So it has an internet users rate of 64.5%. Okay, so in West Africa, you realize that it is kind of it's mixed. Now look at Central Africa. Do you see what is happening in Central? You can see the cluster. Or am I the only one seeing it? Okay, so apart from Sudan, it's quite interesting that Sudan has about it is in its percentage is higher than the threshold. But you come to Chad, okay, Nigeria is in West Africa, so we can't count Nigeria as part. Cameroon, wait, is Cameroon West Africa or Central Africa? West Africa, right? Somebody help me my geography.
It's in West Africa. West Africa.
Okay.
Okay.
That's I should have to go back to school for a geography lesson. All right, but you can see that even if anything, just this area, okay, has some concentration of countries that are lesser, that have their penetration rate lower than the threshold. Okay, so you can see that here. Then when you come to Southern Africa, apart from Botswana, which is quite surprising, well, it is above because this okay, so it's 78. So Botswana is above. Okay, Botswana is above. So I probably have to be careful on okay, this one is below. Somalia is below. Congo is below. But Botswana is above, just 1.9, negative 1.9%. Then I'll probably was the threshold 80, or who remembers the threshold? Was it 80 or 70? I think I've missed it up here. Anyway, but at least the graph, the chlorograph is just supposed to show this kind of, we can also say it's a heat map because we can give it a heat map, but because it's a map,
Hello, sir. Hello?
Hello, dog.
sorry, I went off. Anyway, we are at the tail end, so can you hear me?
Yes, sir,
Yes,
yes,
we
sir, we
can.
can hear you. We can hear you.
Yeah. So yes, so that is it for today. I don't know whether are there any questions on what we've looked at.
Sir, please, I want to find out the map of Africa, the one that you just showed now. It's quite
Sorry, your line is breaking. I
informative.
can't hear you.
Doc, please, can you hear me now?
Yeah, it keeps breaking. But you go ahead and let me hear. Let me see. Let me hear whether who is speaking. Can you go ahead?
Okay, Doc, please, it's Priscilla. Please, I was saying that the map of Africa, the one that we just looked at, is there a way we can import the graph? Sorry, the map.
Sorry, come again. To import the graph. You want
No,
to copy
sorry.
the graph.
No, the map.
You want to copy it.
Yes, please, to Excel. I'm looking at, sorry, not to Excel, to PowerPoint. I'm looking at maybe when you're having a presentation and you want to use something like this, and then as you click on the various countries, you'll be able to speak to the issue. Is there a way like that? Thank you.
Unfortunately, I'm only getting bits and pieces of what you are saying. I think my internet is not helping. Can you come again, please? Sorry.
Sir,
Priscilla.
yes, sir.
Yes.
Sir, I was asking that the map of Africa, okay, is there a way we can copy this map to PowerPoint so that maybe if you're having a presentation and you have to do something like this and you want to speak to the issues, as and when you click a country, you're able to talk about their internet usage and every other thing. Is there a way we can go about it, moving from Python to PowerPoint presentation? Thank you.
Okay, I'll try to answer you. The line has been breaking, but I'll try to see if I understand what you said. So this more or less like sending this one to say PowerPoint, and then when you are speaking to it, you can be putting the cursor on it to show the issues. Is that it?
Yes, sir. Yes, sir.
Is that what you're saying?
Yes, please.
If
Yes.
yeah, okay, yeah, your yes has even been truncated. Am I the only person who couldn't hear her fully or everybody? I want to make
Yeah,
sure it's
we
not
could
my.
hear
Sir,
her.
sir, we had her
You could
fully.
hear her. Oh, okay, so it means it's from my end. Okay. All right. So for this, when you take it to, when you copy it to, I think you can you hear me?
Yeah, we can hear you.
Hello?
Hello, we can hear you,
Yes, we
Doc.
can hear
Oh,
you.
okay. So this one, if you go into, when you save it, it's going to be static. Okay, if you save it, it's going to be static. But you can use a markdown. So that's another a markdown, or there's something called there are there are other packages. Okay, thank you. So there are other packages where instead of presenting it in Word or PowerPoint, you present it more or less like a web-based form. So maybe in your presentation, when you get there, you click on the link and it take you to the web, and then you can have a more dynamic, or when I put the cursor on. Because I think if you can confirm, you can go to the one which are saved in the figures, and you realize that it is static. Okay, you realize that it's static. It is not. It doesn't change, or you don't see the countries as and when you put the cursor on the country. So that will be another kind of package that will allow you to make it this dynamic. I don't know whether I've answered you.
Yes, sir, you have. Thank you.
Did anyone hear me at all?
Sir, we heard you.
Yes, Adolf,
So,
you are
so,
not
so, does it mean
Okay.
is the static one that you can copy onto a PowerPoint?
Yes. So you can confirm. So go to the figure folder in your. So I'm trying to also locate mine. Then we can also, if you go into your folder figure, that's as I say, figure folder in your folder, the main folder, you should see the map. So where am I locating mine? Click on, where am I clicking on? Drive, Google Drive.
We can't
Have
see
you
your
seen it,
mouse.
or it didn't save?
We can't see your mouse where it is going.
Come again?
I'm unable to see your mouse, like the cursor where the
You want to
movement.
see my mouse? So in my folder, I have I've done it multiple times, so they've saved. Okay, so you can see this one. So I'm opening this one, the one in the, do you have something like this in the HTML format?
Yes, dog.
Hello, can you hear me?
Yes, dog, we can hear you.
Can you see my screen? Oh, I'm not sharing my
Yes,
screen. I'm
we can
sharing.
see your screen. Yeah, we can see.
Okay. So I'm opening this one and it's opening on in the web browser. It's still turning. Has someone been able, do you have this one in showing in your an HTML format?
No, sir.
Okay, people of God, I think I'm having issues with my internet. Can you hear me?
Yes, we can.
Yes.
Hello, make it
Okay.
okay.
Okay. So this, if you open it, this one saved on the internet. I mean on the web browser, not as a picture. But if I should copy this one and want to take it to my PowerPoint, it's not going to be dynamic as we have it here. I mean, if I say dynamic, I mean when I hover the cursor over the map, you can see the names and the other information. Okay, so this one is opening in the browser. So I'm saying that for this one, if you want to actually do this and use that as a presentation,
Sir, Prince, your screen
that,
is not showing. It's not
oh
showing.
dear. Sorry, the way I was busy pointing things here and you guys couldn't see, I'm surprised because I wasn't showing my screen. Let me do that quickly. My Okay, I'm sure you can see my screen now.
Yes,
Yes,
sir.
we can see.
Okay. So again, I'm just asking, do you have that HTML file in your folder?
Yes.
Okay, so when you open it, it opens in the browser.
Yeah.
Sir,
So
please, which folder?
in your output folder, so if you go into your informatics for economics folder, you see that apart from notebooks and data, it has also included outputs. So when you click on output, it has figures and then tables. So go to figures, and then that should be one of the items. So week 5 underscore Africa underscore internet underscore gap map. Okay, Africa internet gap map 2024. Okay, so you have that. In fact, somebody can take the challenge and go and, because we have, this is just for 2024, you can write a program and make it as dynamic enough that it will be moving from 19 whatever to the 2024. This is just 1 year. But we know the data we have is from 19 something. Okay, 19 something, 1990 something. So that from that year to this, so that it will be changing. And then you could be seeing, I mean, when you click on it, it changes. You can click on the year, then it changes. Okay. But as I'm saying, if you want to present something like this in a presentation, you put a link. So this link, you copy this link, for instance, and then you paste it in your Microsoft PowerPoint. So I'm opening one to show you. And definitely know some of you know how to do this already. So something like this. So I paste. Oh, come on. So I right click and then come to link and then insert link. So here address is where I put the link and then text to display. I'll probably write Africa Internet Gap Map. So this is what we will show in the PowerPoint. Okay, so I'm just showing you how to include this in your PowerPoint. It's still, oh, come on. Oh, today it looks like everything is falling apart at the end, but it won't. All right, so I have saved it. Were you trying it as I was doing it, or you are watching to do it later?
No, sir, I was stuck. I don't, how you go into the this thing, the folder.
Have you found your folder?
No, please.
So go online. Where did you open where did you open the notebook that you
My
are
Google
using?
Drive. My Google Drive.
Yeah, so go to the Google Drive and go and find it there. You will find it. That is even much easier. I'm having some challenges here.
It works more when you open it on your drive, but not on the Google Drive. When you open it on the Google Drive, it gives you a lot of data. But when you
Oh,
open it on your drive, it gives you the map.
it gives you the map.
Yeah.
Copy the link into your the URL search bar.
Okay, so I've opened my drive and I have a Collab notebook. And then where should I go? Collab book, I have informative for economists. Should I open the informative for economists or which one?
Yes, go inside.
Yes, open
So,
the economics.
so inside I have data, I have notebook,
And
I have
then
student
data,
materials.
You have outputs there.
you go to figures.
No, I don't have output here.
Then you didn't run the whole code. You didn't run everything.
Yes, I have data, notebooks, student material.
Did you run everything on the live coding?
Yes, please.
You're supposed to show that. Maybe go through the live coding and see whether everything has been run.
So go to the very initial one. Do you have any folder somewhere again? Hopefully you don't have informatics for economics somewhere else. But otherwise, if you go to the very first, where we run the code, the very first code we run, that should.
Yeah. I've seen it. I've seen input. So when I open, I see figures and tables.
Yeah, so go to figures.
Okay.
Then you see, I don't know which browser is your default, depending on
Wk5 Africa Internet Gap.
Yeah, so open that, double click on it and to open. Okay.
It's
So people of God,
it's opening a PDF file.
So you can download it. Download it to your drive and open it from there.
Oh, okay.
Okay. So as I was saying, here we want it to be in our in the PowerPoint so that instead of, let me probably, if I should, would it even allow me? Yeah, so I can save as, and if I'm saving as, it will just save as a picture. Okay, so you can see here. Okay, this one is saving as HTML. Okay, okay. Okay, but again, you can't save it this way onto the Google, sorry, your PowerPoint. It won't give you what you want. It's just going to save the HTML. So here, if you have it, as I said, you copy the link, this link. Okay, if it opens in your browser, you copy this link. You open your PowerPoint where you want to, the slide which you want to open it from. So let me go to another line. You right click. This is, I hope you are following.
Yeah, we are following.
Okay, so you right click, go to link. Okay, look for link on the list. Come to insert link. Then in the address, that is where you paste the link. The text to display, which text do you want displayed? So you want Africa Internet. Sorry, what is this? Internet gap map. Okay, and then the address is where you paste the link that you've saved. So I click on OK. And then if you now go to the display mode, so this is what you see. If it's not in the display mode, realize that when you put the cursor, it doesn't show like a finger, unless you put your hand is on the control before it shows like a finger. But normally you'll be on the presentation mode. So in the presentation mode, when you hover the cursor around it, you can see that it turns into a figure. You click, I mean a hand, you click on it. If this one comes, just say yes. And when it opens the browser, and then you can present from here. Okay, you can show it from here. Okay, I hope it was helpful. Who asked that question? Was it Jennifer?
Hello,
Priscilla.
sir.
Priscilla, sorry, Priscilla. I hope you followed.
Yes, please.
Hello,
Okay.
sir.
Yes, who is calling? Joseph.
Joseph. So I've copied the link and I've opened the PowerPoint. What should I do again?
Hey, Joseph. Joseph.
Sir.
Right click. Open, go to your right click. Have you right clicked?
Yes, please.
Then you go to look for link. Can you see link? Can you see link?
No, there's no link.
There is a link. Have you right click and you can see cut, copy, all the
Yes, cut, copy,
yeah,
paste,
so go
question.
down. You keep going, you see link.
I have
Which
searched hyperlink.
yeah, hyperlink. It means you're using Windows 10. Is that it? Sorry,
Yeah.
Microsoft Office, an older Microsoft Office. Maybe that's why. So hyperlink. So click on the hyperlink.
Oh, okay. Okay. I've seen it.
Yes. So when you click on the hyperlink, you will see this displayed. Can you see this one? Do you have the same thing? On top
Yeah.
says text to display.
Yeah. Yeah. Yeah.
Yeah. And then that is where you type maybe Africa Internet Gap Map. Then down there you see address. So that is where you paste the link.
Oh, okay.
Yeah. Okay. So guys, let me probably, so since I'm here, let me show you something. So this one is when you are going to what? Is it existing file or web page? So if you're going to existing file, you can select an existing file and then you can open the file within PowerPoint. Let's take, for instance, a Word document. You saved your graphs or let's say your tables in a Word document. You can also link it here. Okay, so if I should also select some folder or whatever from here, let me see which one can I. So if I say, I hope yeah. So if I click on this, so this is a Word document. So what name do I want appeared? I just write H. and I click on OK. So this one has been linked to the document inside my local drive. So here also, when I come and I'm presenting, I want to present the table, which looks like too much. Instead of bringing it here, I just click on this. I say yes, and then it should open. So I'm just waiting for it to open. Okay, it's opening on my other screen. So it opened on the, so this is what it opened. I wasn't even too sure what was inside there, but if you saw what I selected, it was disaggregated establishment. If I hover it, maybe we should show, but yeah. Anyway, so in terms of the hyperlink, it can be used for many other things. So you can see the other things that you can link, place in this document, create new document, email address, whatever. All of these are things that you can link in. Anyway, but the first one is what is quite important. So if you forgot that one, then that's fine. All right. Any other question?
Thank you,
Hello?
Doc.
All
No.
right.
Hello, sir.
Okay, that's fine. All right, guys. So thank you very much. So I'm releasing your.
Sir, I have a question.
Okay, I'm listening.
Do we have an assignment for week 5?
So that you have just taken how do you even say it in English?
The
The
wind
wind,
out of your
the
sail.
wind out of my soul, yes. So
Okay.
I'm just going to release it right now. Currently it's
Okay.
hidden. At first it wasn't always hidden, now it's hidden. So I'm just going to unhide it and then you should get access to it.
Okay, so maybe I'll call you. I don't know when I can call you tomorrow to discuss something a bit personal.
Hey, how personal is that personal?
It's a bit personal, sir.
I want to invite the whole class to that personal
No,
conversation.
sir. No, sir.
Uh,
But it has to do with my program anyway.
your program, so not just this course, but your program.
Yeah, this course and the program, yeah. Maybe if I can call you tomorrow or whatever.
I'm not too sure. I don't even know which one you're talking about. I've gone to hide it now. I'm trying to find where I hid it. Mr.
There's still
Hello, sir.
ICT administrator, you can stop recording.
Yes, sir.
Yes, Majid.
Yes, please. I followed I saw the procedure you used to save and then use it as a hyperlink on the PowerPoint. However,
Yeah.
for when I go to my drive, I open. I see the Wk5 Africa Internet Gap Map 2024.html. However, when I open it, it's blank. The rest of the maps are of the charts are showing, but only that one, it's just blank.
Yeah, so it's an HTML file, so you won't see it. So you have to open it, double click it and to open.
Yes, when I double click it, it
Yeah.
opens, but the map doesn't appear. It's just blank. It's just white.
Is anybody else facing that issue? So you run it again. So go to start the entire thing again, or go and run the very first one that we did. The very first, where is it? So where we are loading the packages.
Yes, sir.
Okay, so run that one again and then go and open. So this one. Okay, run this again and see whether you get the same issue or not. Oh dear, I've missed where I hid it. I'll find it anyway. That's my job to do. My job to find things. Okay, guys. So that is it for this weekend. God willing, next week will be our last weekend, and that one will be more of, I think, how would I call it?
But
Can I
Doc,
say an
I
overview?
think next week is an in-person session,
Is
or
it?
it will be.
I've not been told. I've not been informed on that. I've not been informed it's an in-person session, and it's quite. If it's in session, that just probably be frank, that will be quite a little difficult for me. But let's see.
Okay.
Have you already scheduled with the other lecturer?
I think they already know that it's an in-person session.
Then I'm the only lost person in the land of GTUC.
Oh, sorry. I think it's on our calendar
Is it?
for the
Okay.
yeah, for the session. It's on our calendar, but I don't know. So if you
Okay.
can
But
confirm.
come again?
I don't know if you can confirm with ICD, you know.
Yeah, I can confirm, but the probability of having the face-to-face may be close to zero for me.
Oh, I see.
That's good news for me too.
Who is that? You have to go. There's just me. The other lecturers,
Then, Doc.
the other
Hello, Doc.
lecturers,
Yeah.
if they are meeting with you, yes, madam.
Yes, then I suggest that you can speak to the other two lecturers that we have. Then they take the Saturday and probably you take the Sunday afternoon, so that we will do yours online on maybe the Sunday afternoon.
Great
Because for
suggestion.
the two, yes, for the two lecturers, I believe that they will come and then have the face to face. So
This you
if you
believe,
wouldn't
yeah, it
be
is
able
very.
to
So you
make
can
it,
confirm from them first. Evans and Grace, if you
Hello,
can,
Doc.
yeah. So if you can do that and confirm whether they are coming for the face-to-face. But even
Yes,
then, again, the Sunday
they
to
are
also
coming.
be. Come again, they are coming.
Yes, next week.
Ah, then maybe I have to speak to your people and see which other day I can meet you because the Sunday too will be difficult for me. I'm sorry. I'm really sorry. The Sunday will also be difficult for me to meet you.
Oh. So, is it throughout the day? The Sunday, is it throughout the day that will be difficult for you? Or?
then we may have to
If you have to
we
meet
may
that,
have
maybe.
to schedule it within a weekday, in the evening of a
Yeah,
weekday,
but we've
if
been
that's going to be okay.
But sir,
you have been
can
some
we
of you
meet?
already complained, and we've already been sent an email that we shouldn't be changing the time because it's a weekend program and not a weekday program.
Yeah, so sir, can we still meet on weekend but online instead of face to face?
Yes, no, I would have done this till the Saturday, but I learned you guys are. So maybe you can. Okay, I don't know how that's all we'll do because we still have to use the link, and I'll need the IC, the distance guys to allow us in. Otherwise, we'd have had 3 sessions next week. So when you meet the others, morning, afternoon, and then
I think we can take it. We can take it with them and communicate with us later.
So I think online will not be bad, whichever way. Online will not be bad.
Okay. All right. So you Evans and okay. So no, I think that this is just up to me now. Okay. So yeah, I'm trying to still search where I hit this thing. I should have hidden it. But anyway, so I'm still searching, and hopefully you should see it soon.
Sure.
All right. So if there are no questions, we can close here. So definitely your homework will come.
Sure.
All
Thank
right.
you, Doc.
Thank
Have
you
a
very
nice
much,
day.
Doc. Thank you very much, Doc.
Thank you very much.
And Doc,
Thank
thank
you.
you very much for your consideration. It won't happen again. We
Yeah,
are grateful. Thanks.
thank you all for thanking me.